Right. We are live on a post-holiday Friday. Jonathan, how's it going?
Good. Post-holiday here in the US for our Independence Day. For everyone else, it's just another live stream Friday.
Right. And honestly, I feel like that probably most of our viewership is not in the US.
Based off the analytics I looked at this morning, that is the case. So
Yeah. Well, cool. Did y'all do anything fun for the holiday yesterday?
yeah, we had a local parade, and for the little kiddies and marching bands, and there's a surprisingly large number. Well, we had two bagpipe marching bands, which I was surprised at. There more than one in our area, so that was fun.
Nice.
How about you?
I didn't really do much. It's been super hot here. In fact, it's actually 98 right now.
Yeah.
Um, but we have a pool like in our apartment area, and so our house is the favorite place for people to go in the summer. So we had some folks over and sat by the pool for a bit, but that was pretty much it. Ate dinner with some folks. But no typical 4th of July activities, just hanging out.
That's awesome.
Cool. All right. Well, we have some stuff to talk about today. Um, Let me get this where I can see all the comments. So we had a hackathon a while back, and we talked about some of the things. In fact, I think I actually demoed maybe the like very early stages of this, but I think in general at Goliath we kind of keep an eye on uh devices of different types, right? Like all the way from like smartphones down to uh sensors, right?
Yeah.
And so I think the obviously when the Rabbit R1 came out, or I guess the Humane AI pen came out before the Rabbit, or at least was announced before. I think that was a hot topic maybe in our Slack, especially with all of the things around MKBHD kind of doing the takedown of them, and then the Verge kind of piling on and all that kind of stuff. But I like to think of us as just curious people, right? We're just interested in how things work, and naturally with something like this where there's a lot of hype and also critique about it.
Mhm.
I think it's natural for us as like technologists to want to be like, okay, well, what is real here, and what's not, and should this exist? Like what's the differentiation, that kind of thing. Um, and so I don't remember how. I feel like there was like rumblings of like, oh, we should build an AI device, or we should build the Humane AI pen or something like that for a while, and then eventually I feel like you were kind of pushed me over the edge. You were like,
Yeah.
I mean, just do it then. Like, you know. So, and also I will say, and I feel like we harp on this a lot on the stream, especially lately. Um, which now my camera and screens are misaligned here, but the our infrastructure now allows us to add things very easily.
Yep.
And so it's very easy for us to integrate different services, and write, something really quick and throw it up there and gate it to just a, subset of devices, which is what we've done here. But anyway, to stop beating around the bush, I guess, we took this uh, Core S3, the M5 stack Core S3. All right, look at that bokeh effect. You love it.
Ooh, that's
Um,
fancy.
and basically turned it into an approximation of like the Humane AI pen or the Rabbit R1, and saw how fast we could do it. And it's also, as you might guess, since it's just an ESP32 with some peripherals, a lot cheaper. I think this was like $50, and of course, like that was with zero cost optimization whatsoever, just an off the shelf, like one off order. So you could really bring down the price uh, quite a bit. But while I was working on that, which we're gonna get to and play with this and whatever, you also were diving into the other side of this, which would be kind of like more the hardware side.
Yeah.
So tell me about how that went for you.
Yeah, and maybe start with like the Humane AI pin, the Rabbit R1. Maybe start with the caveat there. Like, these are both impressive. Well, one is probably more impressive than the other. Engineering feats on the hardware side with a software component, and really what piqued our interest initially was the hardware, and like the Humane AI pin in particular is trying to do a lot of very impressive very hard things in a very challenging form factor. At the same time, there's software that needs to go along with it. And this is kind of the whole story of does the hardware meet does the hardware and software together meet the vision of the hype, but also like, is it even possible? Right.
Right.
And I think the thing that kicked off the thread was like, wow, that Humane pin is doing an incredible amount of stuff. And I'll start out with like kudos to the folks who worked on that, the electrical and mechanical. Very impressive hardware.
Well, kudos to all of them, but especially
yeah,
like,
yes,
I'm glad that y'all worked hard. Your electrical and hardware folks maybe had a little more ingenuity and
and really constraints. But it was this sort of like I think the premise of this exploration is like, well, okay, so you have this hardware component and you have the software component. The reviews came out of like what the software can actually do, and it's like, okay, well, is that like $700 worth of hardware necessary to deliver that same level of software? So really, like, we iterated on not just the what kind of device could we do to match the software capabilities, and we're gonna show off the software, but like how small, how lookalike could we get? And we actually, I think I threw away, but we even prototyped some 3D printed versions of the Humane pin to get like this general
got one right
factor.
here.
Oh yeah, awesome.
So this is I think you designed this, and then Chris lives near me, as is frequently talked about on the stream, and so he is my 3D printer because I do not have one. But it's a pretty simple piece here. If you have this in the full case, the Core S3, it doesn't actually fit in here. But actually, I'll just unplug this for now. You can take this apart, and there's two boards in here. This is not really working for the focus, but there's two boards in here, and really the ESP32 and all the peripherals are really on the top, and then the bottom is power delivery. So there's a battery in here. So you could make this a lot smaller than it is. And we might
like
even
small.
Yeah, right, exactly. But anyway, it turned out being more work than this wasn't our top priority at Golioth, it turned out. But and just getting the camera to be able to fit where we wanted it without having any control over how this board is designed ended up being kind of challenging.
Yeah, and so I held up this alternative board. This is from Seed Studio. It's their Shao line. It is also an ESP32 S3. I think even similar PS RAM and flash with an onboard microphone and camera. I mean, this thing is amazingly small. It's just a little bit bigger than my thumb. And we were trying to see if we can get that form factor. But like Dan was saying, this overall project it was a hackathon project and kind of an exploration of an idea. And really, the software is where we wanted to push the theory of like how can we match the software capabilities. And so tried it with a pin form factor, and actually where we ended up right now is a cuff. If anybody is video game enthusiasts or the recent Netflix special Fallout, it's kind of like inspired by a Pip-Boy. And it's mostly done. You might be able to see some tape in the camera there. But what we really wanted is just a way for us to interact with the device. The pin form factor is kind of hard with the screen here. You can't really see what you're looking at. And so this one also allows us to hide some crimes in terms of just using the S3 kind of out of the box. It's actually kind of usable. I've never had one of these or even a toy like this, but it's all easily accessible from your wrist. And what other things you might need to do in a post-apocalyptic world?
Yeah, right. And there will certainly be LLMs in the post-apocalyptic world as
Of
well.
course.
So I feel like that was one of the things that we started out mostly talking about the Humane pen. I think because it kind of got like a little more attention. Also, like you said earlier, I think we are more intrigued by the hardware than I mean, the Rabbit, is kind of just an Android phone. So so it was, I mean,
Turns
like,
out.
yeah, great for them, but they're not. It's more a uh, feat of product development maybe than technical.
Yeah, and the industrial design by teenage engineering is always lovely. But yeah,
Right.
we really kind of honed in on the humane as an anchor hardware.
Yeah, and that's another reason why. So like a good point of something that we we weren't able to do doing this in very limited time is develop like the projector technology that they have. So like
Oh
there's
my
some
god.
and I think that's one of the things that stuck out to me in watching some of the reviews is that it's not like there is some really technically impressive things. It kind of reminded me of the Vision Pro a little bit, which like the Vision Pro I think is much more useful probably. I've never actually used one, but the like it's like the level of investment, time, and energy, and focus, and whatnot to create like the projector experience. I'm sure was massive, right? Like I'm sure that is not. I mean I have never seen that on a device that small before, and like seems rather responsive as well. Um, but it's like, why do you need that though? That's like kind of the thing we ran into. But anyway, because we have a screen and not a projector, obviously a pen that's facing outward um, is less useful. I guess we could just say like the whole screen is like essentially kind of like the button. And then you could actually display outward messages, which might be cool,
Yeah.
or could be uh, hazard potentially. Because you don't know what the LM's going to give back.
And
Um,
just commenting on the sort of the projector, it's pretty clear they probably just ran out of runway, or Steam, one depending on how you define that, and really did an amazing job on that. Also, people criticize the battery life, and I was like, wow, that's an amazing battery life for what they're packing into this thing. So it really depends on if you're coming from the technical audience
yeah,
or not. But there's a lot of analogies to the ill-fated Juicero, which I get the analogy, but I actually think it's a little bit wrong here, and this is why
yeah,
we wanted to preface this of like the hardware is actually very impressive here. The Juicero, from all accounts, was a reasonable product idea. Yeah, subscription, fresh juice, but extremely over-engineered, even from like the perspective of what this thing is supposed to do. Like they designed custom motors and milled all these gears. Like it added an extra zero for no reason. And there's been a lot of meme juiceros since then. I actually think both the Humane AI Pen and the R1 is trying to solve a very hard technical problem,
mm-hmm.
and that it was just not possible to do with today's technology on the overall product vision. But as kind of your exploration is like, well, if you were to take what was the goal of them and how they could achieve today, like you could actually do it for far more cost effective, like this $50 off the shelf development
Right.
board. So I think this like anchoring on the technical vision they're trying to solve for and missing the mark versus like I don't know, solving the wrong problems
Yeah.
with the G0.
Well, I feel like that one of the critiques is like, well, one of their goals, stated goals, was to like get people away from being on their phone all the time, right? Like to separate you from that and have a more like productive or positive relationship with your technology, which I think is like regardless of if you think that even the hardware and technology is bad, right? Like if you think that, I'm like, it's pretty hard to argue with that mission. I think that's like a very worthy goal, right? Um, the issue is if you like have a uh like even though phones may be bad for us, we like them a lot. So it's going to be very difficult when someone already, like if you have your phone on your person, then the Humane AI pen is doing like way too much, right? Because you have a
Mhm.
much more powerful device right there. Like I was actually thinking about if the Humane AI pen was just like, Bluetooth connected to your phone You know, like if it was in your pocket, right? Like the battery life could be way better, right? Like it would
Yep,
be
yep,
doing way
yep,
less on
yep,
device.
yep, yep.
Um, but like it's against their mission, but they had to knock it out of the park like so far
Yeah,
to do it, and I just don't think it got there. But maybe like I don't know. They've especially I think the AI pen specifically, they've continued to like ship a lot of updates, and I know there's like all the rumors about them like selling and like whatever, but I like I'm not totally convinced that like if they can hang around that they won't get there,
yeah,
because
yeah,
like they obviously have a lot of talent on the team, and I know it's a bunch of ex-Apple folks and that sort of thing. But I'm not like that's not like out of the question for me, which I feel like is not popular to say.
yeah. And there's the consumer electronics world, and then there's the technical delivery. And
Mhm.
consumer electronics, I worked a little bit in that sector. Is very fair weather, and kills products because of opinion. Even if they get corrected.
Mm,
Um,
mhm.
and I think maybe the fact that they have a bunch of ex-Apple people is both a blessing and a curse, in the sense of Apple's, since the iPhone, has pretty much um, you know landed blown products out of the park on their second or third iteration,
Mm,
and creating
mhm.
categories on the second third. They're kind of like known to be like second mover leaders. Like the watch was pretty
Yeah.
terrible at the beginning. The tablet was pretty terrible. And think about it now, like they literally defined the market on both hardware and software. And it's harder to do, as I think, as a startup that's not
Yeah.
Apple. No, you have that pedigree, so like they don't have
Yeah.
they don't have the luxury of a V2, V3, like the same as a former employer.
Yeah, yeah, I've heard that, like, critique of, folks leaving Apple, that they have, like, this incredible design sense, but, like, you just don't have the runway to stick around. But I don't know, I mean, like, it seems like they have pretty good funding, so you never
Yeah,
know. Um,
I did see
I
one. I saw my first human
Oh,
AI
really?
pin. Yeah, I was at a kids park with my daughter, and
Mhm.
someone was using it. They weren't using it. They had it on their person, and it was clearly on, but it wasn't being for the few seconds I saw. I'm like, "Oh, what is
Yeah.
that?"
That's cool.
Yeah,
Well, so I want to, do a little bit of demoing, and then there's a couple other things I wanna talk about in terms of, like, um, things that make this way less capable than those devices, but that are not manifested in the user experience,
cool.
which I think is a like subtle thing that I think is important. But I want to show just like using it. There's one thing I will note. I mean, I've already shown this, right? It has both the OpenAI and Anthropic logos here. That was one of the things that I felt like was important about this, because we make a lot of noise all the time about um, giving our customers and users choice, right? Like we don't want to constrain. We ingest all your data and send it somewhere else, right? And we don't want to constrain
Yep,
where
yep,
somewhere else is, and we also don't want you to be stuck on that forever either, right? So we like to give you as much choice. Well, I thought, naturally, like that's on one side of the kind of pipe that we own. Um, on the other side, why not do the same thing, right? Like allow you to talk to either one. Like I specifically like, I know a lot of times on Twitter and whatnot, folks are posting like comparisons of a prompt to like OpenAI or
yep,
Anthropic.
yep.
And I was like, wouldn't it be really cool if you could just kind of like switch between them on here? So anyway, let's actually do that.
Yeah,
Do you have yeah, go ahead.
I was gonna say, like, also the kind of the prompt, if you will, of the project that you decided. Like, what was the constraints? What was like, what do you want to achieve
Mm,
as you're going through? Like, this is what this is doing, or from that. 'Cause I don't know if
yeah.
we've gotten to that level of detail yet in this
Yeah, I
pen
don't I
today.
don't think so. But do you have a prompt that we can start off with to kind of
Oh
show?
yeah, I was looking for some fun prompts. I was looking up quotes from iRobot, but I couldn't find anyone I really liked. But what are the three laws of robotics?
Oh, okay. I like it. All right, so I'm gonna try. This is I unfortunately was doing some work like right. Well, not unfortunately, I guess it's, what we do here. I was doing some work right up until we got on here, so I didn't get set up as much as I wanted to. I wanted to have it where folks could see it and I could also prompt it, which we're going to try. Also, let me know on the audio because my mic does not pick up the audio coming out of here very well. Okay. Anyway, okay. So we're going to start with OpenAI. Prompt is, what are the 3 laws of robotics? I also suspect we're going to run into one of the limitations here. So that'll be fun. So I'll hit the OpenAI button. What are the 3 laws of robotics? All right. So now it's thinking. And like some of those AI devices, sometimes it thinks for a very long time.
Robotics are a set of rules created by science fiction author Isaac Asimov. They are 1. A robot may not inch.
Could you hear that?
Yeah, you could hear it was faint, but yeah, it definitely came through. It was starting to do the right answer.
Yeah. So we hit problem number 1, which is the audio buffer for the response is fairly short. And I do some prompt engineering, around this by wrapping whatever you ask in like a please be succinct or whatever and how you like explain it. But we do run into that pretty frequently. But let's ask Anthropic or ask Claude, I guess, and see if it gives or at least starts to give a coherent answer as well. What are the 3 laws of robotics? All right, so it'll think. I didn't have as much time to spend on the UI for like the
3 laws of robotics are a set of rules devised by the science fiction author Isaac Asimov. They were introduced in his.
Okay, so that's pretty interesting because I think that was word for word the exact same answer. I don't know if
Yeah,
that came through, but
I couldn't because it was the soft. I couldn't tell. I mean, but they both seemed like they're going the right direction.
yeah. Well, I think they might have been pulling from the exact same source, which I think is interesting. In fact,
Yeah.
actually, let's see. We're gonna boost the volume here real quick.
Do you save the audio, or is it all in memory?
It is I save it on the oh, that's true. I could play it back on my machine here. No, it's in memory on the service too. Well, I was gonna bump up the volume if I can find where I don't I don't actually know what the max volume is on this. So we're gonna see.
At least I could hear the words. It was just faint, so I don't know if the folks on the stream have any issues.
Yeah, let us know if you could. Okay. So anyway, what happened when we clicked the button? Which we can actually pull up the code here in a minute as well, because we want to make this open source here pretty shortly. So when we prompted the device, basically it starts listening on the speaker. I actually wrote a blog post last weekend about using the external RAM on the ESP32 S3, which is allowing me to buffer all of this in memory. So that's why it only takes like 5 seconds of prompt and response, is because we are actually reading it all into memory, which is going to run out quickly on a microcontroller. So anyway, we read it all into memory, and then we do a blockwise upload to Golioth and our AI service, which is not publicly available. If you would like to access it, let us know. But our AI service and indicate which we would like to prompt, and then it basically takes that response. And because of some limitations of doing blockwise upload, download, request, response, it actually caches that, and then we subsequently ask the service for the response back using an ID, essentially, to be able to correlate them together. But what it's doing on the back end is actually no matter what model you end up interacting with, it is using OpenAI because it's taking the wave file for the audio that's recorded and uploaded. It is doing speech to text with Whisper, and then it's taking the text response from that and then using that as a prompt to either AI or OpenAI or Anthropic, then getting the text response back from that and doing text to speech on that. And so it does take a bit of time to do that. Most of the waiting, actually, though, is getting it off the device to the service. The turnaround is actually quite quick, right? Because we're doing everything in the cloud, and it's relatively small transcription as well. So that's generally how it works. One of the things that I think I was curious about when diving into these other devices that we're kind of like building an approximation of was if they were what they were doing on device. Because there's a couple of different ways you could kind of slice and dice this. One, you can upload the audio, right? That's what we're doing here, mostly for simplicity. You could do the speech to text on device, upload the text, get the response back, and then do text to speech on the device, right? You could do some permutation of those. In this case, I didn't try to find any models for doing text to speech on device. I think that would be pretty challenging on a microcontroller, just based on some of the other domains that I've looked at doing kind of like edge inference with. But that would be an interesting thing where we'd be uploading and downloading drastically less data in that case. But that's kind of like the round trip experience for this right now.
Yeah, and I remember we looked briefly into the different libraries available from Espressif. So ESP32 S3 is one of Espressif's latest chips. They have a lot of different open source libraries, and I'm sure even more advanced libraries around AI and edge processing. But like pretty much they're all just wake words. You can get pretty good at wake word and multilingual, even on something that's a $2 chip. But it seems like the state of the art for at least Espressif is anything beyond that you just can't do on a microcontroller. There are newer sort of niche co-processors there that have come out, and some companies are investing heavily in just general like neural network stuff on chip. But we haven't seen a lot of examples of it, and certainly not in a $2 chip with Wi-Fi and all the other goodies that come along with it.
Yeah, and I don't know if this may be what you're alluding to, but the Cortex M55. I don't know. I don't think there's any devices out with that yet. Are there already?
Yeah, M55 and I think the U55 is the even newer one. It was just announced. I might be getting this wrong, but yeah, the ARM has a neural network IP as well as software. And so if you're familiar with like SIMSYS, which I can never remember what it stands for, there's SIMSYS NN. And so companies who buy the IP can then create neural network accelerators using SIMSYS NN, and it kind of works apparently. But yeah, I believe they're at Embedded World this year, they announced even some newer stuff. But the companies I'm thinking about, like ALIF Technologies is one that has accelerators for microcontrollers, and oh, cool. That makes sense. Cyberon is one of those other ones from Mubi.
Nice. The I was looking at the Cortex M. Let me share this real quick. On the Cortex M page, it's pretty limited in terms of the. Oh yeah, is it Aleph? Is that how you say it? Aleph?
I thought Aleph was with an E. Like, yeah. But I don't know. Yeah, there's some pretty wild processors they've been announcing lately.
Yeah. So anyway, there's not if there are some, but not many that are supporting this right now. But it does look like there's quite a bit more coming. I know that doing image detection there's some somewhat capable models for that on devices. So that's another thing, in addition to like wake words or things of that nature. We've actually been, if folks follow me on social media, we've been working recently with this OpenMV cam module. I guess I could stop sharing my screen and you could see us better. This little OpenMV cam module, which is pretty slick. They have a lot of the development experience around this, pretty dialed in. So it's all MicroPython, which I don't love, but I appreciate why it is. But yeah, it's got a NXP 1060 microprocessor on it. 1062, yeah. 1060 series on here. And it can do some pretty crazy things, actually. And I know they've put a lot of work into optimization of the image processing on this, and it's using TensorFlow Lite models for inference. So yeah, there's some pretty neat things you can do for sure.
Yeah, and I remember another company that you can license. It's called Pico Voice. I actually did a project with a long time ago. I thought they got acquired, but I guess they're still around. PicoVoice.ai can do some pretty compelling things on edge and some things on microcontrollers.
Interesting. Actually, I was just thinking, I just Googled if there were Cortex M55 chips available, but we could just ask and see.
Oh,
it came out in 2020, so we'll see. Or the ARM announced it in 2020, so I'm guessing it's going to say none, but let's see. Are there any ARM Cortex M55 implementations? I also boosted the volume, so we'll see if it's a little faster or a little louder now.
Yes, ARM has announced the Cortex M55 processor core, which is targeted for use in AI and machine learning applications. While there may not be commercial products,
Got cut off,
cliffhanger.
but did it come through for you that time, though?
Yeah. That's better.
Nice. Oh, and it looks like micro speech on OpenMB is coming soonish. Oh, that's cool. Need to look into that. Cool. Well, I thought we could also look into the code a little bit and see what's going on here, as we like to do around here. So I'll pull this up, and for folks at Golioth, I'm going to scoot back over here now. For folks at Golioth, they know that I have had some issues with screen sharing. So if I suddenly drop off this call, it's because my machine doesn't like it. But I think it is working now. All right, let's do just this window. It hasn't kicked me out yet, and it looks like it might be coming through here.
Seeing it, and you're still here, so.
All right. And I'm fairly certain I've redacted all of my credentials in here as well now. So I actually, one of our colleagues, Mike, was doing some audio work this morning on the Core 2, which is kind of like the predecessor to this off-the-shelf board that we got. And he was asking about this, so I actually needed to get the code pushed up so that we could put our heads together there. So it's pretty straightforward. Actually, the one of the most fun things I think throughout putting this together was getting more familiar with LVGL. So for folks who haven't used that before, it's basically, I think, like the top graphics library for microcontrollers, and it is really intuitive. And we can kind of actually, I'll look at what I've done here. So in this UI init, let's jump over to what's happening. So first thing is, it's really easy to get icons into LVGL, because I just pulled the SVGs off these various sites, including ours. And then there is let's see if it'll let me share again, an online image converter. Yeah, here it is. Let's see if it's gonna. Well, it's going to make me do it this way, but I think this is pretty neat. Yeah, so you can just upload and then select the color format that you want, and it'll basically give you back a C file with just the byte array of that image. And then all you have to do is declare that macro, like I was showing just a moment ago, and then you can use that anywhere you want in the UI that you're designing. So what I'm doing kind of from the beginning is I'm first leveraging the board support package in the ESP32 project. So they basically make a lot of this a lot easier for you. So I started out with Zephyr. Actually, the Core S3 hasn't been added upstream in Zephyr, which I did get it working, which I need to upstream those things, but there is not like driver support for the ADC or anything like that. So it's just going to be, once again, it was a hack project. Anyway, setting up the display and then setting up some styles that we're going to use throughout. So basically just styles for the screen, styles for the button, styles for that spinner that I showed earlier. I really wanted to do this kind of like black and white theme. So there's a bit of converting to make that kind of stuff work. And then just setting up each of those screens. So I guess y'all didn't really see the boot screen. I can do it quickly here if I just reset. But we flash the, let's see if I can. We flash the Golioth logo up there when it's booting up, which is kind of neat. And so setting up that screen, setting up a variety of other ones, you can basically do Flexbox with LVGL, which is incredible and made it very easy to design this stuff. So you can see, yeah, I'm doing, declaring the row alignment, space evenly. Like it's pretty much mapped exactly to CSS, which is pretty incredible. Very easy to get started. And yeah, setting up those buttons with the callbacks, and in the callbacks, I'm just passing, which service I want to talk to. This is actually the endpoints that I'm calling. So it's like .ai/OpenAI. So in the event handler, I just basically pull this argument back for whichever button was clicked, and then use that when crafting the path for the URL. Yeah, the rest of this stuff is pretty straightforward. And then I just have these functions to basically switch between them. One thing that I hit kind of at the beginning was in the event callback at first. It took me a little while to learn a little bit about how the kind of like render loop works in LVGL. So I passed this event handler when I set up the UI. And in the event handler, when I was just, scratching this out to start, I was doing all of the like getting the audio, sending it up, whatever. And I kept trying to change the screen in there, and it wouldn't change. So just stay on the buttons. And the reason for that is because it's a LVGL event handler. So I'm basically giving it, the event handler, and it is then going to run it, which is going to then disrupt the render loop, right? So it's not going to render anything that I'm doing in there, as you might guess. But it took a little while to get familiar with how they were doing that, and whether they were, using multiple threads or something like that. But ultimately, I just used a binary semaphore here to basically trigger here. I'm just waiting in a loop and saying, hey, whenever you get a button press, and there's a bunch of events that come off a button press, once again, kind of similar to the browser, go ahead and give on that semaphore, which will allow us to progress here. We switch over to that listening, which you couldn't really see, but it just displays some text that says, I'm all ears or something like that. We copy a wave header into the audio buffer. And this audio buffer, we can actually, well, no, it doesn't show it here. Let's see where my audio buff is declared. Oops. Yeah. So this is and I'll grab that blog post link. This is what I wrote the blog post about earlier this week. And we go. Effectively, this attribute here just allows you to specify where you want this placed in memory. So I initially was doing dynamic allocation into the SPI RAM, so the external PS RAM um, for the ESP32, and I think it is 8 MB. I think, which on chip you only have like 500 kilobytes, something on the order of like 500 kilobytes. And so literally just this 1 MB buffer was not going to fit. I wouldn't have any room for it. I wouldn't have room for it or anything else. But because I had this other 8 MB um, memory, I could just read into there. Now, of course, there's ways you could optimize here to not have to read it all into memory and hold it like that. This was mostly just a quick hack. I will say that I started off with trying to write it to flash. So I would read into a buffer from the I2S from the microphone and the ADC, and it was too slow. So I don't know, Jonathan, you might remember when I posted the first audio sample, and it was like, it sounded like it was sped up, but it was really just, catching every so often in the sampling. And so writing it out to flash I was using the SPIFs file system, which is SPI file system for flash, which is really convenient to use, but it was too slow. So ended up just saying, well, I've got the memory. I'll read it all into a buffer. But yeah, I thought it was pretty neat how they just had the macro there for you to add the attribute to stick it in external RAM.
That is cool. And I quickly looked up the ESP32 S3 supports up to 16 megabytes of PS RAM, which that sentence is still shocking to me. That such a thing is possible.
I know. I'm like, what am I gonna? The world is my oyster here. Yeah. Another thing I was thinking about, which here, I'll see if I can open it here. They're quite big, so it might get kind of upset. But I was thinking about actually putting the images as well in the external RAM, which I believe I could do by just annotating them as well with the attribute. But anyway, that's neither here nor there. So anyway, we read from the microphone. Once again, this is made super easy because of the codec library and in the board support package. So I get to skip over a lot of stuff. If you're interested in looking into that, I think I should have a blog post pretty soon on looking into what the board support package is doing here. But yeah, so read it all into the buffer with the offset of 44 for the wave header. And then do the blockwise post, which is a new API in our firmware SDK. And so I'm just sending it to that /.ai. Up here. /.ai with the endpoint. And the endpoint is the callback that I assigned over in the UI here. So on the OpenAI, I pass that callback with the user arg of OpenAI, and here Anthropic, and that basically ends up over here in the endpoint. And the way this API works is you give it a callback, this read block buff. And if we jump up here, it is basically going to get called repeatedly and pass you an offset, which is just the block that you're at. I think we actually changed this from offset to block number. I think Sam might have done that to make that a little more clear. I'm on a slightly stale version of the SDK here, or a non-release version. And so, yeah, I'm just basically going through that buffer that I saved in external RAM and copying it into the block buffer about a kilobyte at a time. And then it's getting sent as blocks, getting transferred up. And then it hits our gateway, goes through that to the AI service, which that's kind of what allows us to just throw up new services whenever we want. And then that does the speech to text, text to chatbot, and then text to speech, and then sends that back down, which we're getting down here at download. And then we're playing it over the speaker.
So that new service, or the service we built for the hackathon, uploading the audio file, sending it to the API, is it worth showing it, or is it like actually the simplest part of this entire project?
The underlying service?
Yeah.
Yeah, sure. I can share the code.
But like maybe there's that question, like as you're pulling that up, how does that compare to figuring out encoding, storing in PS RAM? Like, is this a hard service to build?
I would say honestly, neither side was very hard. Maybe that's not a great advertisement for me. But neither. I mean, like I'm leveraging a lot of libraries on the ESP32 side for sure, which made that pretty straightforward. I don't know, getting up to speed on LVGL took a little bit of time. Definitely the what I'm about to show here took like, I don't know, 30 minutes, and that was all just reading the docs for how we need to structure the payloads.
All right, so we'll put that number in the back of our minds. The service took about 30 minutes, plus or minus, and this is supposed to replicate the capabilities of these devices. So like, let's look at it and see how hard this is.
Yeah, and once again, like, I will emphasize, it took 30 minutes, and it looks like it took 30 minutes. So keep that in mind for all the audience. Also, not something that's publicly exposed. So I'm actually going to scroll through this really quickly and see if I have API keys in here anywhere. No. All right. I was good and did not.
The 25 of the 30 minutes was to find where the key should be stored.
Right. Exactly. Okay, so I have a little server here, just running on port 8080, doing some very naive muxing on the handler here, where I'm just saying if it's prefixed with, or not prefixed with .ai, then just respond 200 okay, basically. Or maybe that's, oh, I remember I was this generic, actually, if I jump up to it, let's see.
And this is Go code for those who are not familiar.
Right. Actually, with the reason why I put this in here is I wanted to see if I was sending any other requests. So this just dumps it to standard out, so I can just see the output of the request. But so on the upload here, we basically take it and so on the body of the request is going to be the wave audio file, and all I do is copy that into this multi-part form for an HTTP request. So that's where I'm creating the form file, and then this IO copy. So doing everything in memory here. Once again, 30 minutes. Doing everything in memory here, just copying from that body into the form, and then submitting that to the transcription URL, which is the Whisper model. You can see actually I'm specifying Whisper 1 up here. And yep, setting the authorization, et cetera, doing the request, making sure it's valid, and then unmarshalling the JSON. So you can see one of the nice things, well, actually it was kind of nice, the Anthropic, right, was started by folks who loved OpenAI, and they basically just copied the API in terms of structure, not in terms of what they're doing behind the scenes. But it's almost the exact same for their services. They don't offer, at least to my knowledge, could be wrong, they don't offer like a Whisper type model. That's why I'm doing all of the text to speech and speech to text. Also, that's like sort of a commodity. I mean, Whisper is open source, right? So I actually thought about even just running it ourselves, but it was a lot faster to shovel it over to them. So anyway, I'm taking the transcription, and it's just giving me text back, and then based on the path here, I am either prompting OpenAI or prompting Anthropic. And like I said, they look pretty much the same. So if we look at prompt OpenAI here, you can see that this is where I'm doing some of the kind of like setup. So telling it, you're a helpful assistant. So basically, like give us an answer back here. I don't actually have the formatting in here for doing the like be succinct. This is just that's why we kept getting cut off. But there's also max tokens, which I'm actually surprised. I feel like some of those responses it gave might have exceeded max tokens, but this is just to make sure that it doesn't keep going forever and give you an answer that never ends. So anyway, make that request, get it back, and then this content here is the text, right? It's the text of the chat response. Like I said, it looks very similar. You can see it's a slightly different response here for Anthropic, and I'm specifying that I'm using Claude 3 Opus. Cool. So I get that back. And then last step is doing the text to speech. So I take the input, which is the answer from the chatbot. I specify the voice that I want, which is Alloy. They have a couple different options. They don't have Scarlett Johansson anymore. And then I specify that I want it as a WAV file. And so when that ends up coming back down, the WAV file is a little bit different than the one we send up. So this is just a simple packed structure for a WAV header here. And so you can see the first thing I do when I get the response back is I just copy the first 44 bytes of the response into a WAV header. And then I end up using that to specify the sample rate and channel and bits per sample for the speaker before I open it up and actually play the audio.
Well, first of all, 30 minutes is pretty impressive even for this, but
well, that was just on the server side, to be clear.
Yeah. No, of course. I think that's kind of the whole point of this. That started this as a thought exercise, right? Like, how complex is that service to build? And if we leverage what we've built upon in Golioth, like, could it just be as simple as we think it is? And I mean, we'll let the audience tell us one way or another, but I think it is as simple as we kind of surmised in kind of armchair quarterbacking the critiques. Like, the software side of this is very straightforward. Capture some audio, send it to the cloud, process it with off the shelf or even custom services. But like, that part is very easy. So not talking about the hardware side, because we talked about limitations of using a microcontroller in this scenario. But I think if we were to answer that question that we provoke people with this event, is like, yeah, it's actually not that hard to reproduce the software that went into these two devices.
Right.
Yeah. How do you feel about it?
Well, I mean, I feel like the other part, and maybe this is a little bit self-serving for us, but like the other hard part about this is connectivity and being able to stand up a service. And like I don't know the total time I spent on this. I don't know what the total count is. It's not that much. As you probably know from getting messages from me at like 11:30 on some nights, like, before I go to bed, hack on this a little bit. And a lot of that was on the UI for the device. So, part of the reason why it was super straightforward is because I can just write that little Go service that is not production ready, but just throw it up behind something that I know is protecting it. And also, in this case, we're using Wi-Fi. It would be extremely easy to do the same thing on a cellular device. It'd probably be even slower. But having all of that out of the way, like the two biggest, or I guess three biggest things I'm leaning on here are Golioth, some of the firmware libraries from Expressive, and then just the fact that like these LLM models are just available on a REST API call. And so it's not super challenging. It's like the I don't even know if saying 90% is a little overzealous probably, but like it's like 90% of it is super easy. It's the last 10% that's really hard.
Yeah.
And I feel like maybe a good way to describe it in comparison to some of those other AI devices is we did like the 80%, once again being like super generous, 80%, and it was extremely easy. They did the next 10% that was extremely hard,
Yeah. Yeah.
but it needed 10% more. Is like
Yeah.
kind of where
Yeah.
I've landed with this.
I
Um,
think that resonates with me for
yeah,
sure.
yeah. And I mean, like, I also don't know, like, one of the things I have questions about is like, are they actually just calling OpenAI like I'm doing? Like, is that what's happening on the back end, or do they have their own models, right? I know Rabbit certainly has made a lot of noise about having their models, and they're doing something, to be clear, like they have a whole other aspect of
Yeah.
this
The sort of
where
virtual assistant thing.
exactly, yeah, and it's uh very frightening. I would never use the Rabbit, to be clear, because you log into Spotify in a virtual machine that they run, like
Yes.
I'm never ever going to do that. And I would also advise no one else to do that. But like,
They
it's
did that. And
impressive.
so yeah,
Yeah.
yeah.
Yeah. Um, and so yeah, I don't know how much if they're doing actually like custom model development, of course that's like a whole other domain that I
Yeah.
just did zero of, right? There was actually for this being an AI device, I did zero model training or any right. Like I
But
just
you
called
did
an
some
API.
prompting. That
I did
counts as a prompt engineer.
right, right.
Add it to your LinkedIn.
Right, right. I am a prompt engineer. Um, so yeah, like I don't know, like I think the interesting thing is that we cut every corner and it's not that much worse. Is
Yeah.
kind of like
Yeah.
my biggest takeaway, you know?
That's the summary quote of the video stream.
Right, right. Yeah. We cut every yeah, that's kind of how I feel after doing it. But I will say that like I don't know. It was intellectually stimulating, and I enjoy thinking about how systems work and trying to replicate them. I think takes you deeper down that path. Also, expose a few things that I think are actually going to, turn into not maybe not directly, but the experiences from them are going to turn into some product improvements on Goliath as well.
And we actually showed some of the more recent, and there's undercover stuff that we've been talking about for a while. You mentioned the blockwise uploads
Mm-hmm.
one. It's a feature we haven't really been promoting, and just the overall infrastructure that we built around the thing that enabled us to do pipelines. Yeah, anything else that worth calling out that we're able to, besides the connectivity and the security and the connection management that already comes out of the box from Goliath? Anything worth calling out in the last few minutes we have?
Um,
Well, let's
I
talk
would
about
say
Blockwise. Want to
stay
talk about
tuned.
Blockwise just for a second, since
Sure.
that's kind of a newer
Yeah.
feature.
Yeah. So we've supported Blockwise downloads for a really long time. And we've talked about co-op a lot on these streams. But we use co-op over UDP. And there's a variety of reasons for that. We have some blog posts on it if you want to get down in some of the details. But UDP is a connectionless protocol. It is also an unreliable transport. So with CoAP, you are moving you're moving reliability to the application layer if you're thinking about like the OSI model. And so um, typically you are going to try to stay under the MTU for all of the network hops that you're going to have between your source and your destination or your two
Maximum
endpoints.
transfer unit.
Yes, exactly. And the reason you want to do that is to avoid IP fragmentation. And so blockwise transfers are basically taking um, a larger payload, so something larger than a kilobyte, um, and um, and uploading it piece by piece, essentially. So, there's lots of protocols support things like this. But effectively, the way that it works is you're passing along additional metadata with each request that has a block in it that tells, what the block size is, what number the block is in the sequence, what the total number of blocks are. And so, like when I'm uploading that audio, there is a bunch of requests and response going back and forth there. And one of the things so first of all, we've done that for a very long time for firmware images for OTA, right? Those are going to be larger than a kilobyte. And so we supported that for a very long time. But we were limited in the size. If you were, not our API, but our firmware SDK was limited in the size that you could upload to Goliath, which cuts off a number of different use cases, such as uploading audio, right? That's going to be too large. And we've worked around that both internally and with a few customers of saying like, we'll basically chunk it up and reassemble it, afterwards. So like maybe we'll stream it through pipelines and collect it at whatever destination and then reassemble. And, we'll even before that, before we had pipelines, we'll base 64 encode this image, and send it through there in a JSON payload. So, but that the main thing with that is like, it was against our ethos, right? I mean, it's inefficient, and we kind of like exist to have a secure, efficient connection to the internet from your device. So we're able to do a lot more now. And now that we support blockwise uploads, not only are we being efficient, but we are also allowing you to do those larger payloads. Now, one of the things that is kind of a bummer about it, right, is that you're doing a round trip for every one of those blocks. And so it may take a long time. In fact, it was thinking for quite a while after I prompted it, which another one of the limitations I'll say there is I had a fixed recording window. It was just over 5 seconds. So like it looked pretty good but it wasn't actually like listening for when I stopped talking, right? So all sorts of limitations around here. But so anyway, you're doing that round trip because we're sending those as confirmable blockwise messages. And so we need to get an acknowledgement from the server that it received it. And that's important with something like audio in this case, because we actually don't want to tolerate packet loss. However, there is a separate extension to CoAP called QBlock, which allows you to do non-confirmable message blockwise transfer. So you can drop blocks, and that's okay. And that can be really useful if you're doing something like streaming audio or video, because you don't have to have that round trip time. So yeah, there's it unlocks a lot of use cases, and there's still some more exciting things we can do in that realm.
Excellent. And probably more things we're going to be working on to make more use cases like this feasible, if not anything but practical.
We might actually have an announcement next week. So who knows? We might.
I think we did say on this live stream.
What is the announcement?
Yeah, I don't know. What is it?
It is a place that you might want some of this type of data to reside.
I actually know of I think the one you're speaking of, but we have so many pun intended pipeline things in the pipeline that I don't know which one you're referring to specifically.
Yeah. I would say that well, I'll just leave it at that. But yeah, we do have a new one it's not we have a new example for folks today.
Oh, yes.
Yes. So
that is you have to meet your quota of doing some pipeline related
why do you think that PR came in yesterday? I was like, "Oh man, the stream's coming up," and I don't think by the way, the term that we've been calling this, we were kicking it around. Right now it's the AI micro, and like I said, we'll make this stuff open source. But the idea is that we'd do this on a bunch of different devices, and whenever new models come out, we'll try it out, that sort of thing. Other people can contribute. Basically, just like let's see how crazy we can get with this, without spending a lot of time on it. So anyway, let me go ahead and pull it up here. The new example that we have, and I think I can demo it too, although as you'll see in a moment, there's a reason why demoing this is sort of dangerous. It goes against the first law of streaming to demo this, which is don't have Slack open. Which why share screen. Here we go. All right. So, new example just dropped. This is not a new. Someone could have done this at any point in time. We just wrote up how you can do it. So it's a Slack webhook data destination for pipelines, which is using the webhook destination. So you'll see this actually looks like a lot of other stuff. In fact, actually, I was looking at the Zapier one that you added, Jonathan, and it's like the same exact thing, right? With a with just a Slack webhook instead.
Yep.
And so there's a couple things that are interesting about this. One, like many webhook services, you have to have the payload in a certain format, which is kind of a bummer if you're sending data from a device, because you really don't want to have like the device thinking about the actual ultimate destination. You want to think about it as an API there. However, we have a number of transformers like the JSON patch one, which we've talked about on here a little bit, that allows you to basically transform a payload to fit a different structure, which is really nice. I actually want to try this here. Actually, maybe we'll do it live to figure it out. But one of the things that I wanted to use this for is when we're all the time like working on firmware that's sending various payloads up to the cloud, and sometimes they don't come through how we would expect. And a very easy way to troubleshoot them is to look over in Slack and have your payloads just coming into a channel and say that. There's also some fun stuff. I didn't get a chance to do it before today, but I was going to change the UI to say prod and dev on here and make a little deploy button to message in Slack when we're deploying to prod and dev. There's obviously better ways to do that with a GitHub action, perhaps, right? But would be fun nonetheless.
Yeah.
Okay, so let's try it out in action.
All right.
Let's give it a shot. I think I already have this created in a project here. Let me see. Okay, share this tab. Slack webhook. So I've already got it here. I have a secret with a Slack webhook in here. So we're all good to go. Also, if anyone's looking closely, there's an Easter egg for the announcement next week that you just saw. So now we're entering the danger zone as I open Slack here. I wonder if I can make it just share a single channel.
Do you, do you have the browser instance?
Oh, that's a good idea. I'll try Slack in the browser.
It's still dangerous.
Right.
Do you want me to screen share? I think I can.
Sure. Yeah, I think we can actually have both ours up here at the same time, right? Which would be pretty neat. Yeah, right. I'm offloading the liability on you right now. Is what's
I'm
happening.
realizing that liability might be too high.
Yeah, yeah.
You know what? How about we drop a video recording of this in a more controlled environment?
What if I have an idea? I have a good idea here. Okay. Well, it's an idea. Someone in the chat, give me a message you would like to send. So you have to have the text in here, and there's a bunch of different formatting you can send. But someone in the chat, or if we don't get something in the chat in the next minute, then Jonathan, I'll prompt you for it. I'm just gonna not to be secretive here. I'm just going to screenshot the channel when it comes through, and then I'll pull that up.
Do we get a prompt?
We haven't yet, so you're up.
All right. IoT is for slackers.
I see what you did there. All right. And I'll go ahead and send that through. And it's already come out over here. Oh, actually, that's not a bad strategy. Hold on. I am going to show it on my phone. I'll show the notification coming in. Let's see if I can make myself bigger here. No? Okay, that's fine. I'll do it like this. And hopefully nothing else ridiculous comes up. Oh my gosh. Well, actually, I guess it'll light up when it comes. This is trickier than I imagined with the mouse. All right. IoT is for slackers. Aha. IoT is for slackers. Yep.
Awesome.
So just like that, you can now just message all your friends right from a whatever device you want.
A microcontroller near you.
Right, right, exactly. The thing that I wanted to try, which maybe if I grab the JSON patch example here.
Hey Dan, I'm 12 minutes late from a call.
Yeah. All right. Well, you could have jumped off at any time. We'll hold this for next stream. Anyway,
what are you gonna do?
Shown a lot of
are you gonna reformat the data?
Yeah, I was just gonna send on a different path and then move it to the text field.
Okay.
Yeah. But folks can imagine it's not that crazy. But anyway, been a good stream. Good week.
It has
at
been.
Goliath.
Yes. And yeah, I really like this exploration. I think we should, as technologists, continue to explore what's possible and where AI with devices, supported by devices, on devices, just like that whole intersection, where it makes sense and where it doesn't. Like, I don't think anyone knows the answers, and we'll continue to have opportunities to explore because people still try to push the envelope.
Absolutely. Well, give your next call person my apologies, but thank you for coming on this stream, and thanks to all the listeners. And I hope folks have a great weekend, maybe a long weekend if you're in the US. So
yeah, thanks, Dad, for hosting. Always great to hang out with you, and I'll talk to you soon.
Cool.
Bye, everyone.
See y'all.